The physical properties of elements determine their uses in society, whether we're disinfecting pools or building pipelines. In science, we organize the elements into categories that describe their physical properties. For example, metals and nonmetals.
Science rules.
Elements that are shiny, conductive, and bendable are classified as metals. Elements that don't have these physical properties are classified as nonmetals. Take a piece of copper. Is it a metal or a nonmetal? Let's test it. If I polish the copper with the steel wool, it looks shiny. When I touch these probes to the copper, the conductivity meter tells me electricity is flowing. Copper is a conductor. And if I twist it, I can change its shape without breaking it. It's bendable. Obviously, copper is a metal.
We've set up a lab to test the properties of metals and nonmetals.
Our 3 sample elements are aluminum, sulfur, and carbon.
We're going to use steel wool to polish the elements and a meter to test for conductivity.
Then we'll test for bendability.
Our first sample is aluminum. We polish it with steel wool, and it's definitely shiny.
The meter shows us that it conducts.
And it's bendable. I can flex it with my fingers.
So it has to be a metal.
Right. Sample number 2 is a solid lump of sulfur. Polishing it doesn't do anything.
And the meter says it doesn't conduct.
And we can see that it's very brittle. So it goes under nonmetal. Our last sample is carbon. It isn't shiny when I polish it.
But the meter says it conducts electricity.
And when I bend it, it breaks. So where do we put carbon?
Good question.
The unusual properties of carbon and silicon make them difficult to classify. Carbon conducts electricity, but it doesn't bend. Silicon is shiny, but it's a poor conductor. They each have some properties of metals and nonmetals. They belong to a unique class of elements called metalloids, which fall between true metals and true nonmetals.
The universe at the very beginning was a very simple place. It was huge clouds of hydrogen and helium, and again a pinch of lithium. After a few million years, the gravity of these clouds would start to condense the clouds into stars, like our sun. In the very center of these stars, the temperatures and the pressures are enormous. The temperature of the core of a star can be 10 million degrees. At these temperatures and these pressures, hydrogen atoms can be slammed together in a process called thermonuclear fusion to produce atoms of helium. And as the temperature goes up and the pressures go up, even more complex atoms like carbon and neon, all the way up to iron, can be produced inside these stars.
Observing the physical properties of the elements lets us divide them into metals and nonmetals. Gases fall into the nonmetals, and metalloids fall in between, showing properties of both metals and nonmetals.